In this lesson, we are going to be looking at Descartes' rule of signs. To start, we're just going to review a little bit about the polynomials I have here. The degree of a polynomial is its highest exponent, and that tells you how many roots, zeros, or factors there are. We have done that before, and we've looked for those roots and zeros and by factoring them or doing the quadratic formula, looking at our calculator and seeing where the graph crosses the x-axis. So in this problem, the highest degree is the highest exponent. So our degree is 3. So that means there are 3 answers to this problem. 3 roots, 3 zeros, 3 factors. For the second one I have here, the degree is 5. So that means there are 5 answers to that problem. When you look at the graphs, this graph here is of 2x cubed minus 2x plus 5. This is a degree of 3. So there are 3 answers to this problem. The only one we can find right now is where it crosses the x-axis. That's the only root we'd be able to find. The reason for that, then, we would say are the other 2 roots must be imaginary because they don't cross the x-axis. So of the 3 answers, there is 1 real answer and 2 imaginary. The cool thing about imaginary numbers, they always have to have a buddy. Always. So you can't have one imaginary number. Think of when you take this square, x squared equals negative 4 and you square root both sides. You get x equals plus or minus 2i. So there will always be even numbers of imaginaries. There can't be 1 or 3 or 5. They always come as a buddy. In the second one here, we have a degree of 4. This is x to the 4th. And so there's 4 answers to this problem. And in this case, you can see that each one happens to be a real answer. It crosses the x-axis. So there are 4 real answers to this problem. Not imaginary. Okay? So what we're going to do now is learn about Descartes' rule of signs. And this you will use when you are not allowed to use a calculator. They actually do this in college algebra and possibly in your pre-calc class depending on who you have, whether you're in high school or college. But they're going to do Descartes' rule of signs and not let you have a calculator for this. This is why we're using it. They're going to have a polynomial given to you with real numbers and a non-zero constant, meaning that's going to say like plus 6 or plus 8. It's not going to have 0 there or no constant. Then it says the number of positive real zeros. So positive real zeros is either equal to the number of sign changes in f of x or is less than that number by an even integer. Sounds really easy, doesn't it? The number of negative real zeros for f of x is either equal to the number of variations in sign in f to the negative x or is less than that number by an even integer. So that all makes perfect sense, right? You can just go do the problems. Sounds super confusing, I think. You don't even know what I'm talking about, right? So we're going to try a problem here. This is what we mean by positive real zeros, roots, factors. How many times the sign changes? So this is a plus sign. See that? And I went from a plus to a minus, so there's 1. Then I stayed a minus, so nothing changed, right? Stayed a minus. Now here I went from minus to a plus, so there's 2. I went from a plus to a minus, so there's 3. And I went from a minus to a plus, so there's 4. So this problem right here has 4 sign changes, meaning you change from positive to negative or negative to positive, and you have to count them. If there are 4 sign changes, that means there are either 4 positive real zeros, or I keep decreasing this by 2. There's 4, 2, or 0. Because there could be 0 if the graph never crosses the x-axis. It's always going to decrease by an even amount, though. So even it could be an odd number, like if it was 5, then it'd go 5, 3, 1. But it has to go by 2's. Okay? Now negative. They replaced all of my x's with a negative x. And then they simplified this. So that's what they did here in this line right here. And then they went ahead and simplified this, and this is what we have for our signs. So negative to negative, nothing. Negative, positive, there's 1. Positive, positive, nothing. Positive, positive, nothing. Positive, positive, nothing. So there was only 1 sign change here. That means there's either 1, or I could go down, not up, but down by 2's. Well, down by 2's gives me negative 1, which isn't going to work, right? I can't have negative answers. So there is 1, let's say, let's be proper grammar here. There is 1 negative real zero. That's what that's telling me. That's what we're going to practice right now, is finding out how many there are. Now, when we say negative real zeros or positive real zeros, we mean positive and negative numbers. That's positive real 0, that's a negative real 0. So that's what we're looking for. Okay? We're just going to kind of practice applying this rule, and then we'll see how it works a little bit more tomorrow even, or our next lesson. Here we find the possible number of positive zeros, negative zeros, and imaginary zeros. So we didn't talk about imaginary yet, so we'll get to that. But the positive ones, I look at what I'm given, and I check for sign changes. So I go from a positive to a negative, there's 1. Negative to a positive, there's 2. Positive to a negative, there's 3. I changed every time. So right now I know that my positive zeros are either going to be 3 or 1, because I have to go down by 2. How many total zeros do I have? Well, I have 3, right? It's a degree of 3. So let's go ahead and fill that chart in. I'm going to say 3, 3, 3, 3, 3, 3, 3. Okay. Now, to find my negative real zeros, I'm going to substitute h of negative x into this problem. So every time I see an x, I'm going to replace it with a negative. Parentheses are very important here. So I'm going to go 4 and then parenthesis negative x cubed minus 6 parenthesis negative x squared plus 8 parenthesis negative x minus 5. So when I reduce this, I have to use my order of operations. A negative x cubed would be a negative x cubed, right? So it'd be negative 4x cubed. I'm just going to keep this going here. And then negative x squared is just x squared. So I actually don't change anything there. 8 times a negative x would be negative 8x, and then a minus 5. So when I go through and roll this, now I'm going to look for my sign changes. So I went from negative to negative, no change, to negative, no change, to negative, no change. So how many sign changes do I have? 0. So I know now that I have 0 negative real zeros. Okay, so we're looking for the graph crosses the x-axis. And again, this is if we couldn't use our calculator. So my choices for my only choices for negative zeros are 0. So I have 0 and 0. My choices for positive are 3 or 1. Since my only choice is 0 for negative, I have no other options. So here I have a total. If I add these two together, I have 3. So how many real zero or imaginary zeros would there be? Well, this whole column across has to equal this number right here. So there's 0 imaginary numbers there. Now here, if I have 1 plus 0, that's 1. I need 2 more roots, don't I? So that tells me I have 2 imaginary roots. That's all this table is. So really, this bottom part of the table, I was given a lot of room, but I didn't even need it. This table's kind of short. So there is my solution. This is my table. Now, again, what this means is my options for my graph, my answers, like x equals 6, 3, and 2. There's one option. 3 positive real zeros. My other option is 1 positive 0, so let's just say x equals 6, and 2 imaginary. So the other two roots would be like plus or minus 2i. There's my other option. We don't know what they are yet, but those are my options. Okay, that's all we're finding out. This was used all the time before kids had graphing calculators because you couldn't see the picture, and graphing it by hand took forever, so we would use Descartes' rule of signs. I even did this when I first started teaching. Tells you how old I am. There were graphing calculators. I had them in high school even, but this was something we taught all of our students about, in like early 2000s. Every kid had to do it this way because not everyone had a graphing calculator like we do now. Now the state requires us to have you have them. So they had to use this. This was the only way they could find the roots. Number 2 then, we're going to try that one. I go from positive to negative. So there's 1, no change. Oh, there's a change. There's a change, and there's a change. So look at that, I have 4. So I have, for number of positive roots, I have 4, 2, or 0. I'm going down by an even number. Now, to find my negative ones, remember I have to plug in p to the negative x. So I'm going to switch every x with a negative x in parentheses. That's all I'm doing right now. If I go too fast, pause the video, catch up with me before we solve. And now I'm going to simplify this. So p of negative x equals negative x to the 5th power, since it's an odd exponent, is going to stay negative. Negative x to the 4th power is going to become positive. So when I times that by negative 6, I'd get negative 6x to the 4th. Negative x cubed is going to stay negative. Times a negative 3 would be plus 3x cubed. Negative x squared would become positive. So plus 7x squared. And then minus, oops, hold on. Negative times negative is a positive, plus 8x, how about? And then plus 1 at the end. So when I look for my sign changes, I go from negative, negative, no change, negative, positive, there's 1, positive, positive, no change, positive, no change, no change. So my number of negatives is just 1. There's 1 sign change. I don't have to go down by any. So my total number of answers should be 5. So 5 is going to go in this column. And my options for positive are 4, 2, and 0. And since I only have one option for negative, I plug that in. And again, when I add up across, this should equal that total number of 0. So since I have 4 plus 1 is 5, I'd have 0 imaginary. 2 plus 1 is 3, so I'd need 2 more roots to make 5. And 0 plus 1 is 1, so I'd need 4 more roots to make 5. So those are my options for my answers. I can have 4 positive reals and 1 negative, 2 positive reals, 1 negative, 2 imaginary, 0 positive reals, 1 negative, 4 imaginary. Those are my options. And then the rest of this chart isn't even needed here. And I will always give you more of a chart or less than you need. You're not going to be able to guess by how much you're given there. Next one we're going to do is number 3. This one, I'm going to look at my changes in the beginning. So I have 6 total, right? And I go positive to negative, so there's 1, negative, positive 2, positive, negative 3. So I've got 3 options here. So my options for real positive is 3 and 1. So now let's plug in that negative. So we'll say r to the negative x equals negative x to the 6th minus negative x to the 4th plus negative x squared minus 1. So these are all even. So this would be, when I take it to the 6th, it's positive x to the 6th. This would be a positive x to the 4th, but since it's a minus, it's negative x to the 4th. Negative x squared is plus x squared, and then minus 1. So when I look for my sign changes, I go from positive to negative, negative to positive, positive to negative. So my options, I have 3. So my options for negative are 3 or 1. Now remember, my total roots are 6. So I have 6 and 6. So I can have a 3 and a 1. And what could that be paired with? Let's just pick one of these, huh? It could be a 3 and a 3. Then I have a 6 and a 6. I'm going to keep this 3 and a 1, and that could be paired with this one, a 1 and a 1. See how I've given every option, every combination between 3 and 1 for positive and 3 and 1 for negative. I'm using every combination, kind of distributing that to both if you want to think of it that way. Now remember, they have to equal here. So I'm going to say 3 plus 3 is 6, so I have 0 imaginary. 3 plus 1 is 4, so I need 2 imaginary to get to 6. 3 plus 1 is still 4, so I still need 2 imaginary. 1 plus 1 is 2, so I would need 4 imaginary to get to 6. And there's my table. The last one, I want you to pause the video and try it, and then I'll put the answer up here for you. This one I got the options of 1 and 2 or 0. So my number of real roots is 3. I can have a 1 and a 1, so a 2 and a 0, which makes this a 0 and this a 2. All of that's dead space. Make sure if you have questions on that, you come see me tomorrow.